Chris, are you there?
Yep, I'm here.
Yeah.
Sorry, I was trying to
Okay.
unmute myself and you unmuted me.
Yeah, no worries. Cool.
All right, let's get going. So, welcome to Common Analysis Services Design Mistakes and How to Avoid Them. Julie has already introduced me, but here are all of my contact details and websites and books and everything. So, by all means, please read my blog and follow me on Twitter and visit my web pages and all of those things. What are we going to talk about today? Well, this session is more of a gentle stroll through some of the things that I see on my consultancy engagements where people ask me to look at their cubes and I kind of breathe in slowly and say, well, I wouldn't do it that way. So there isn't a big overarching theme. We're just going to look at some things that I see quite often done in Analysis Services Multidimensional cubes that you may want to fix. And it's not a name and shame session. You know, it's not. I'm not going to say that you're an idiot for doing any of these things. These are just common things that people do wrong. And by all means, if you see that you've done some of these things, go away by all means and change what you've done. And hopefully you will see some benefits. And the question is, why is good design important? I think with Analysis Services Multidimensional and MDX, maybe even more so than lots of other enterprise software, good design pays dividends. It's very easy to get something working in Analysis Services Multidimensional, even if it isn't the best possible solution. And the trouble with Analysis Services cubes is that you get something working, it gets into production, people start using it, and sooner or later it may well come back to haunt you. It might just not give you exactly the right performance, or your design mistake coupled with some new calculation you want to implement doesn't really perform as well as it should do. People live with not a great user experience, but they can work with it, but then slowly over time they kind of think, well, actually this isn't great, maybe we should be looking at another tool or should be redeveloping this. So good design is important in the long run. You may not see benefits from making the changes that I'm going to recommend immediately in the short term. You may well do, hopefully you would do, but in the long run I think some of the things that I recommend will pay off. And let's go on to our first topic. So without me telling you on a webcast what's good or bad design, BIDS or SSDT-BI, whatever you want to call it, Visual Studio will also try and suggest some good design hints. This is what the blue squiggly lines that you see in Visual Studio are. They're Analysis Services, or rather Visual Studio, applying its own best practices for cube design to what you've done. Now, usually I and most of just about everybody else ignores the blue squiggly lines. They appear all over the place. But when you're reviewing what you've done, maybe just before you're about to put your cube into production, it can be a good idea to go through what Visual Studio is actually telling you about your cube design and just see whether it has a point. So if we go to Visual Studio, and here is a Visual Studio project that I'll be working with for all of my demos, you can see that in a few places we've got some blue squiggly lines. So here, for example, under the quarter attribute, we've got a blue squiggly line. Here, under the date dimension, we've got a blue squiggly line. Now, if you see a blue squiggly line and you put your mouse over it, you will actually see the suggestion that Visual Studio has made here. So in this case, it's looked at my dimension, it's looked at my attribute relationships, and it said, okay, well, try and define your attribute relationships as rigid where possible. Now, what it's actually suggesting here isn't really the point. What I want to show is that it's giving you a blue squiggly line. It's giving you a suggestion. It will also show these suggestions when you build your project. And remember, a deploy also includes a build. So I'm going to do a build here, and then I'm going to go to the error list dialog. And here you can see that I've got 5 warnings, and I've got a list of all of the suggestions that Visual Studio has made about my project. Now, like I said, it can be a good idea to go through all of these suggestions and see whether what Visual Studio is suggesting is actually something that you want to be able to take on board. Now, in some cases, some of the things that it's suggesting, you may disagree. You don't want to do these things. So maybe on the date dimension, we don't actually want to define relationships as rigid. So in this case, you can just dismiss, and you can add a comment when you dismiss, and click OK. And now the blue squiggly line has gone. The warning has disappeared from the error list. You can actually see a list of all of the dismissed warnings with comments, and also a list of all of the rules that Visual Studio will apply to your project by clicking on your project, right-clicking on your project rather, going to Edit Database, and then going to the Warnings tab. And here on the Warnings tab, you can see a list of all of the rules. And if you want to just disable some rules because you don't think they should apply, you can uncheck here. And then here, if we've got something that we've dismissed, you can just click the re-enable button, and you will see that the blue squiggly line has come back on the date dimension here. And I think this can be quite a good thing, a good exercise to go through, like I said, when you're about to deploy into production, just to check whether you've done anything stupid, whether there's something that you want to, reconfirm. So now let's move on to specific areas, specific design mistakes that I see people make. And each one of these topics that I'll cover we need to ask 3 questions about. So first of all, we have to describe what the problem is. Secondly, what bad things will happen if I do what I've described. And then thirdly, what can I do to fix it, especially after I've gone into production. So each of these 3 topics, we're going to ask these 3 questions. So the first problem that I see right at the beginning, usually when you're building an analysis services cube or a dimension, it's quite common that you need to have some kind of extra columns or some changes to the underlying relational database that you're working with. So for example, if we go to Visual Studio, here's something on the employee table. If we explore the data in here, we've got a first name column and a last name column. And actually what we want is a single column with the first name and the last name concatenated. So we need this for the name of an attribute. We've got a couple of options here. What we could do is very quickly and easily in the data source view create a new named calculation which just says first name concatenated with a space concatenated with the last name. And that does the job. That works. The other option, of course, is that we can go back to the data warehouse and we can add an extra column onto the table, and then that involves talking to the database developers, and then maybe we need to update the ETL, so you've got to talk to the ETL developers as well. So that's very time consuming and not great. And obviously changing the DSV is going to be the nice, quick, easy option. And in a lot of cases, that's probably okay. But I would say it's not a good practice and something you should try and avoid. Because in some cases, what you might find is that you end up writing SQL, especially if you're doing complex calculations or joins between tables in your data source view, you might find that it hurts processing performance. Now, the other week I had an email from a friend of mine who was saying, oh, well, I'm processing a dimension. I need to join two tables in the dimension, but the SQL that's being generated hasn't got a great query plan, and I'd like to put a query hint in. Now, it turns out there's no way to use query hints in the SQL that Analysis Services generates, and that's because all of the SQL that Analysis Services generates gets wrapped in another SQL statement, another SQL statement. You have sub-selects, all kinds of stuff goes on. And this meant that actually we couldn't put a query hint in. So this is typical of the kind of problems that you see on large or more complex cubes with processing performance. And it means that you can get something working in your data source view, but you end up being in a situation where processing performance isn't great, where you get locked into something that isn't ideal. So it's always much better, and I would say, to push the work back to the relational database, push it back to SQL Server. Now, as I pointed out, it's not going to be an ideal situation if you have to go away and change tables, change ETL. So I would say the best option is to create a layer of views back in your relational database and use these views to populate all of your cubes and dimensions inside Visual Studio. Now, the advantage of doing this is if this layer of views is purely there for your use for Analysis Services, it will give you the option to go away and add these columns, join these tables together. And it will mean that you can do this quickly, and your development work won't be interrupted. But the good news is that once you've done that, the change that you've made, the work that you've done is visible to all of the people working on the relational database side. All of the DBAs, all the data warehouse developers, all the ETL developers. And they're going to be able to look at this, they're going to be able to tune the queries or tune any calculations that you've done. And more importantly, they will then be able to say, well, I can see Chris wants a column with first name concatenated with last name. They can then, in their own time, go back and add these columns to the underlying tables, add these columns back to the ETL, and they can alter the view that you've done. They can take the calculation or the join away because they've done the work back in the relational database, further back or in the ETL, and then it won't interrupt you later on after that change has been made. So I think there are a lot of benefits to having a layer of views inside the relational database which you use to build all of your Analysis Services objects, precisely because it allows you to make changes very quickly and easily so your Analysis Services development isn't interrupted, and it allows all of the guys that are developing the relational data warehouse and the ETL to see what you've done, tune it, and then also incorporate those changes back into what they're doing, and then they can update the view, and your database and your Analysis Services development is not interrupted either. So that's the best practice there. Now, moving on, another problem that I see with a lot of people's cubes is unfriendly names. So what do I mean by this? Well, let's imagine you're building a new dimension. So you go through the new dimension wizard and you say, well, okay, I want to build a date dimension. Here's the dim date table. It's my date dimension table. Let's just go through the wizard. Let's check everything. And bingo, we built a nice dimension very quickly. And it will end up looking something like this. It's got absolutely everything in it, so surely that's going to be a good idea. Well, no, not exactly. What I always say when you're thinking about designing Analysis Services objects like dimensions or measures or cubes, you need to think about Analysis Services as a kind of user interface. After all, Analysis Services is the layer on top of your data that allows your end users to go away and build their own queries, explore the data themselves. And if you have an unfriendly user interface, then you will find that your end users can't use the cube as effectively. So if we go, for example, to Excel, that dimension that I just created will end up looking something like this. We've got names all over the place. We've got calendar quarter, date key, English month name, fiscal year, lots and lots of random stuff. So if we were looking at, for example, an attribute full date alternate key, it's got the date in it, and we know that it's a date key on the date dimension table, but will your end users? They'll probably be wondering, well, what is a key? They might see dimensions called dim product or dim customer, and they'll be thinking, well, why does it have to have the name dim in front of it? Well, it doesn't really. It's not something you'd want to see on a report. They then will not only be confused, but they'll probably be a little bit embarrassed, because if they're showing the reports they've built to other colleagues, they will then have to go away and explain why the dimension is called dim product or why something is called full date alternate key, when it's actually just a product or a date. And of course, once they've had to explain that, they're probably going to have to fix these problems in their reports, and this is when they end up copying and pasting data out of pivot tables to make the data look nice, and that's when you end up with stale data, multiple versions of the truth, and all kinds of bad things. So I would say you need to think about naming when you start designing the cube. Because yes, you can go away and rename objects after you've put your cube into production, but the problem is once you start renaming objects, this is going to start breaking calculations, MDX calculations on the cube. It can also, if you're renaming dimensions or measures or anything like that, it can break existing queries and reports that your end users have built. And finally, and maybe a little bit more obscurely, if you ever need to work with XMLA, which you may well do, for example, if you're creating partitions on the fly, or you're doing backups or restores or something, you'll find that even once you've renamed an object, so if we go back here and I'll say, well, actually this shouldn't be date key, this should be date, you'll find that the ID of the object, if we go to properties, will always reflect the original name. So even though I've renamed this object date, the ID of the object, the unique identifier, is still date key. And if we're working in XMLA, then date key is what we're going to see in XMLA. And quite often when I'm working with people's XMLA, I find it quite difficult to find out which exact attribute I'm working with, because I can see an ID, I have to check back to Visual Studio to see which name attribute has got the ID that I'm seeing. So the best thing to do is when you start to build a new dimension, go through the wizard, and when you run the wizard, get the names of your attributes correct inside the wizard, because that's the only way that you're going to be able to get matching IDs and names. And of course, you shouldn't go back and just make up these names yourself. These are names you should agree with your end users before you even start designing your cube. Now, another related problem when you're building dimensions is the problem of unnecessary attributes. So we've already seen how names can be confusing, but another problem that new analysis services designers often have is understanding exactly what an attribute is. It's easy to think about an attribute, or to think that an attribute is just a column in your dimension table, but really it's not. You need to think about an attribute as a real-world entity, something that an end user would understand. And the classic example of an unnecessary attribute is a situation where you have a key column on a table and you've got a name column on a table, and you end up building a dimension which has got something key and something name in it. So for example, we go back to Visual Studio and we go into dim date, and we've got, or we did have, date key and full date alternate key attributes. So these things actually represent the same thing. Date key was just a numeric surrogate key built from the dimension table. Full date alternate key is the actual date column that contains a human readable date. Why do we need both? Well, actually we don't. We need just a date attribute. We don't need two attributes for date, and indeed we don't need to see the surrogate key column at all. Now, the problem with unnecessary attributes is not only just usability and cluttering up your UI. These attributes will slow your dimension processing as well, because remember, each extra attribute you have in your dimension has to be processed. That's going to increase your overall processing time. And there are going to be other problems later on as well. So for example, if your dimension is cluttered up with lots and lots of key name type attributes, you'll find that it's much harder to come up with an effective aggregation design later, because you might have aggregations designed on attributes that, well, actually you didn't really even want to use in a query anyway. So the fix here is to go through your dimension, delete any attributes that your users are never going to use. And I know that your end users always say, oh, well, I want to have everything, because they don't know what they want. But you have to really sit them down and say, well, what do you need for this particular report, and only build the attributes they actually want. And then also look for those key and name pairs and say, well, actually, I don't need two attributes, one for a key, one for a name. I need to go through and I need to merge them to a single attribute. So here on this dimension, this was my date key attribute, and you can see that it uses the date key column here. I've renamed this date. Actually, what I want to display when I view the dimension inside the browser is not the surrogate key, the date key value, but I want to use full date alternate key as my name column. So now I've got a date attribute. Each date is uniquely identified by the date key. The name of the date, the display caption that I want to use is full date alternate key. I don't need this attribute at all either. I can delete this. I've got one less attribute. I've got an attribute with a name that makes sense, and I've got a good combination of keys and names. And also remember that even if you have to have an attribute in a dimension, it doesn't have to have a hierarchy. Each attribute will automatically have a hierarchy built for it, which can take quite a long time for processing, or it can increase your processing time, certainly. And if you can get away with showing an attribute just as a property of something else, then consider setting the attribute hierarchy enabled property on that attribute to false. So for example, here in Visual Studio, on my date attribute, I've got attributes for day number of month, day number of week, and day number of year. Now, maybe I don't actually want to drag and drop day number of month or day number of week into my pivot table, but maybe I'm just interested in showing day number of month, for example, as a property of date. Well, I can do that quite easily by setting attribute hierarchy enabled to be false. Now, in this case, you can see the icon for day number of month has changed. And what this means is now, because there is an attribute relationship between date and day number of month, then day number of month is only going to be visible as a property of date. And if we go back here, and for example, we show the old date key attribute here, we can show properties of an attribute in Excel by right-clicking on the attribute once it's in a pivot table, show properties in report, and then choose the properties that you want to see. And now you can show these properties inside your pivot table, but you don't have to have an attribute hierarchy for them. And indeed, showing values as properties in this way can also give you better query performance on large pivot tables. So this is a good thing to do. Another problem when we're talking about dimensions, the problem of parent-child hierarchies. So parent-child hierarchies are very flexible. They're great when you've got that recursive type structure inside a dimension. So for example, on my employee dimension here in AdventureWorks, I've got a dim employee table which contains a flat list of employees. And for each employee, I have the key, I have the employee's name, but I also have the parent employee key. And what this means is that we can join this table to itself, and we can find out the employee that each employee reports into. So in this case, Guy Gilbert reports into parent employee key 18, which, if we go down here, is Joe Brown, who reports to employee ID 23, which is Peter Krebs. And of course, we can build this as a parent-child hierarchy, and it works. And now we can drill down. Great. But what are the problems with parent-child hierarchies? Now, sometimes you can't get away from using a parent-child hierarchy. But parent-child hierarchies come with performance issues. They can slow down query performance quite a lot. For example, they prevent you from building aggregations anywhere inside your parent-child hierarchy, which can be a big issue. And to be honest, they're slow anyway. And you'll also find that if you're doing advanced calculations using scoped assignments, for example, or you're trying to set up dimension security, parent-child hierarchies complicate things a lot. So I'm not saying always replace your parent-child hierarchies, because that's not always possible. But there is an alternative. And that is to use a ragged hierarchy instead. So that's to flatten your parent-child hierarchy into a regular level-based hierarchy, and then use the hide member if property on that hierarchy to selectively hide members in that hierarchy. So this can be quite a long and difficult and time-consuming thing to do, but this is one of those situations where BIDS Helper comes to the rescue. BIDS Helper, if you haven't heard of it, and if you haven't heard of it, go away and install it. BIDS Helper is a free download for Visual Studio, built by members of the Analysis Services community, which adds lots of extra cool functionality to Visual Studio for people developing using analysis services, reporting services, and integration services. And it's got a whole load of great extra things that it adds as new menu items and buttons inside Visual Studio. So once you've gone away and downloaded BIDS Helper, and I think anybody working with analysis services should always install BIDS Helper, what you'll find is that after you've built your dimension, you can, your parent-child dimension, to turn it into a regular flattened hierarchy, you can just right-click and click the Naturalize Parent-Child Dimension button here. So if I do this, BIDS Helper opens up a dialog, and it says, well, there are a number of things that I need to do in order to take this parent-child hierarchy and turn it into a regular flattened hierarchy with hide member if. First of all, it needs to create a data source, a view in the relational database to do the flattening. Then it needs to add that view to the data source view. Then we need to create the new analysis services dimension. Then finally we have to add it to the cube, and maybe we need to process. I'm just going to click OK here. And bingo, everything has been done for me. So let's see what BIDS Helper has done here. If I go back to SQL Server, we can have a look at the view that's been created in the AdventureWorks database. So here is the view, and we can see what it looks like. It's taken that parent-child structure and it's flattened it out, so we've got one column for each level in the hierarchy. And if we script it out to the query editor, You can see the SQL that it's generated to do that. And this is not trivial SQL. This is something that may take you quite a long time to write on your own. So even just doing that, BIDS Helper has saved you a lot of time. It has then added this new table to the data source view. It's gone away and built the analysis services dimension for you. It's built the user hierarchy, and it has even set the hide member if property on each level. And now when I process this dimension, what you'll see is that it looks pretty much exactly the same as the parent-child hierarchy, but it isn't a parent-child hierarchy. And of course, having done this, we're going to be able to get probably slightly better query performance, or maybe radically better query performance as a result. There is a trade-off here. We have to know how many levels the parent-child hierarchy went down to, and also how many levels it would ever be likely to go down to. BIDS Helper allows you to create a fixed number of levels, more levels than are currently present. So it's not a perfect solution, but in a lot of cases I find that this does give you an important performance boost, and it doesn't take away any functionality. Another common problem that comes up when you're thinking about designing your cubes is the question of, do I build one big cube with lots of measure groups in it, or do I create lots of small cubes with just one measure group in it? Now, this is one of those problems where there is no one right solution. You know, in some cases it can be correct to build one big cube. In some cases it can be correct to build multiple smaller cubes. So let's have a look at what the problems with building just one big cube are. Well, some of the problems that I see with this are from people who've almost been too successful with analysis services. They've built a cube, people have loved it. They've added more data to the cube, people have loved that. They've added more calculations, they've added more and more measure groups, and eventually after a couple of years they get to the situation where they have about 20 or 30 measure groups and 40 or 50 dimensions. Now, having a really large number of dimensions and a really large number of measure groups, again, leaves you with a very cluttered, complex, difficult to use user interface. And while this might be okay for the users who've grown up with your cube, any new users might get really confused or intimidated when they see this. Probably more importantly, it becomes very tricky to develop, because even just adding a new dimension or adding a new measure group involves ticking a whole load of boxes, setting a whole load of properties, and it's very easy then to make a mistake. Also, adding calculations sometimes, it can be very difficult to work out what that calculation does in all scenarios, because there's just almost too much to test. There are other issues with having one big cube. For example, you might find that one of your dimensions, some bad data has got in and needs a complete reprocess. If you do a full process on a dimension, any cubes that include that dimension also need to have a full process. And in this case, you might have a dimension that's only linked to one or two out of your 20 or 30 measure groups, but doing a full process on that dimension will take the whole cube offline, means you have to do a complete reprocess. So the one big cube approach is not very fault tolerant. And finally, and this is again something that only happens on really large complex cubes, but it's something I've seen, if you have one big cube with lots of dimensions, lots of measure groups in it, and not all dimensions are associated with all measure groups, query performance can suffer. It's just one of those things, the more complex the space of the cube, the harder it is for analysis services to come up with a good query plan. But on the other hand, there are problems if you split your cube up into lots and lots of little cubes with just one measure group in. And the big problem here is that if you need to analyze data from multiple cubes, you have a big problem. Really, the only way to get around this issue of analyzing data from multiple fact tables in a single pivot table is to build one big cube. And this is almost the overriding factor that means that what the one big cube approach is better or preferable to the multiple cubes approach. Now, if you think about trying to fix this problem, and you've got one big cube and you want to go to multiple cubes, well, the issue isn't too hard. The main bit of functionality you will use if you have one big cube is perspectives. And a perspective can make your one big cube, of course, look like lots of smaller cubes. So, for example, you might have sales data, marketing data, finance data in your cube, in your one big cube. But if the people in the finance department only want to see the finance data, you can create a perspective that contains only the measures and dimensions from the finance measure group, and then it looks to your end users like a separate cube. Your finance users can connect to it, they can use it, and of course then the complexity issue for them is solved. You can of course use linked measure groups and dimensions to split out a single cube into multiple smaller cubes. I'm not a great fan of linked measure groups and dimensions, simply because they tend to increase the maintenance overhead, and there is again a slight query performance overhead from using them. So there are solutions to make one big cube look like multiple smaller cubes. Perspectives is the main one. It doesn't solve all of the problems, but it solves the usability problem. The big problem comes when you've got multiple cubes and you come up against that problem of, well, how do I query all of that data together in a single query or for a single calculation? Really, I would say here maybe the best option would be to start again from scratch. Now, there are options to get data from multiple cubes into a single query, like the lookup cube function in MDX, but this performs really, really badly, and it's something you should avoid. And again, you could use linked measure groups to join your multiple cubes together into one big cube, but this involves duplicate MDX code, it increases your maintenance overhead, and, you know, for example, structural changes involve objects having to be deleted and recreated, which makes your deployment much, much harder. So I really recommend that if you're thinking about this issue of do I have one big cube, do I have multiple smaller cubes, always start off with the one big cube approach unless you have really good reasons to use multiple cubes. Because even though the one big cube approach isn't perfect, it's probably the least worst out of the two options. One issue that I see quite often when I'm tuning MDX calculations is people like to have an over-reliance on MDX. Again, it's one of those things where you find that maybe you need to go back and, for example, change the relational database, change the data source, change your ETL, and you don't really want to do it, and you think, well, actually I can get around the problem in MDX. This can work in the short term, but again, it can lead to query performance problems. So I'll give you an example. I had a customer a couple of years ago that was doing some reporting by country, and their reports were very, very slow. They had lots and lots of complex calculations, some of which I couldn't tune. But inside their report, they had an MDX calculation that grouped a number of countries up together into a regional level. So they had lots of countries in Europe, and they wanted to see a European Union total. So they didn't have anything in that dimension that grouped countries together into regions like the European Union, so they created yet another MDX calculation that just summed up all of the countries in the European Union to a European Union total. Now, like I said, the reports they were running were very, very slow. The calculation to sum up everything for the European Union was pretty trivial. There was no way that I could optimize it in MDX. But what I found was as soon as we got rid of the calculation completely and added a new region attribute to their dimension, which they were then able to use in their queries instead of the MDX calculation they were using, even though that calculation that they had been using wasn't on its own badly written, it just meant that as soon as Analysis Services could choose a single EU member on an attribute and a dimension, all of the other calculations that we were having trouble tuning suddenly became much, much faster. because it was the combination of complex calculations plus this extra calculation to group everything up to the EU level that was causing Analysis Services to have a fit. As soon as we got rid of the unnecessary calculation, Analysis Services suddenly decided that it could create an efficient query plan for the calculations that we did need to do in MDX. So the answer is always use MDX as a last resort. Always try and design as much into the structure of your cube, into the structure of your dimension, and only use MDX for the calculations you can't do in any other way. Now, I've given you one example. I'll give you another example. So I had a customer where they were doing some very complex calculations in MDX, which I was able to, and their reports were running for 7 or 8 minutes. In this particular case, they were effectively trying to recreate a many-to-many relationship in MDX. As soon as I redesigned their cube with many-to-many relationships rather than the MDX calculations they were using, their reports went down from 7 minutes to under a second. So you can get some really big dividends in terms of performance just by redesigning your cube to try and put calculations or even just parts of calculations back into the structure of your cube. And there are all kinds of scenarios where this is useful. Moving on, let's talk about aggregations. So aggregations are a very important feature for improving performance of the Analysis Services storage engine. And people kind of know that aggregations are a good idea, and quite often they just run the aggregation design wizard and build some aggregations, and they think, great, I've built some aggregations, that's all I need to do. But of course, building aggregations is not enough. You need to make sure you are building the right aggregations. Now, there's nothing wrong with the aggregation design wizard as such, but it's a little bit hit and miss. Sometimes it builds aggregations which aren't useful for the queries you're actually running. And of course, if you've built aggregations which aren't actually being used, they're not going to improve your query performance. And of course, it's going to waste time processing because these aggregations will need to be built, and they'll need to be stored, and they'll make your processing time much slower. So what do we need to do? Well, we need to design some aggregations. We probably want to do usage-based optimization as soon as possible, because this is going to allow you to build aggregations based on the queries you're running. But more importantly, if you're looking at queries and you're trying to tune a query and you think, well, maybe this query could benefit from aggregations, check to see whether it is indeed using aggregations. How do we do that? Well, if we go back to SQL Management Studio and we clear the cache, so here's my clear cache command. Here I've now cleared the cache, and if I go to my first query, here is a very simple basic MDX query. How do I know whether this query uses aggregations? Well, having cleared the cache, I can start a profiler trace, and here the important thing to do is on your profiler trace use the get data from aggregation event. So the get data from aggregation event will be fired every time Analysis Services gets data from an aggregation. And what we'll see here is that if we ask for sales amount by date, we see no get data from aggregation event. Our query is not hitting an aggregation. But if we go back here, clear the cache, and look at the same query but at month level, run the query, you can see there's the get data from aggregation event. Our query is using an aggregation. So this is how you can see whether your queries are using aggregations. Always look for the get data from aggregation event in your traces. And if you've got aggregations, if you've got queries that aren't using aggregations, build aggregations. But also, if you've got aggregations that are there and not being used, it's a good idea to go away and delete them. So how do you know whether an aggregation is being used or not? Well, run a profiler trace, run that get data from aggregations event, and leave it running for maybe a couple of days or a couple of weeks. That will give you a list of all of the aggregations that are actually being used by queries, and then that means that you can go away and delete all of the aggregations that aren't being used. And you can delete aggregations in your cube by just going to the Aggregations tab, going to the Advanced view, looking at your aggregation design, and here you can see a list of all of the aggregations, and you can just delete a single aggregation by clicking somewhere in the column that represents the aggregation and pressing delete. And deleting unused aggregations is just going to make your processing much faster, and it shouldn't, if the aggregation is genuinely unused, it shouldn't affect query performance at all. Now, another more subtle problem that I've seen with aggregations is unprocessed aggregations. So I had a customer where I went in and spent a couple of days designing aggregations for them. So I knew they had a good set of aggregations, and we did some testing, went into production, the aggregations were working, they made the queries fast. And then a couple of months later I had a call from them saying, hold on, our queries have gone back to being slow. We don't understand what's going on because the aggregations are still there. But for some reason they don't seem to be improving performance anymore. So I had a look at the queries that were being generated. The queries hadn't changed. What was going on? Well, what had happened is they'd changed their ETL. They'd gone from reprocessing their entire database every day to doing a process update on their dimensions, and then just reprocessing the partitions in their measure group that contained the latest data. And what was going on was that they hadn't realized that after you do a process update on a dimension, sometimes aggregations on partitions will be dropped. So if you're doing a process update on a dimension, you no longer have to do a process full on your entire cube. But some aggregations on some partitions may well be dropped if there has been a change in the dimension, and that change that means that the data stored in your aggregations is no longer correct. So for example, you might have an aggregation where you're aggregating data up from customer level to city level. If you do a process update and your customer has moved from one city to another, the stored total, the aggregated value at the city level you might have created will no longer be correct because a customer has moved from one city to another. Now in that situation, Analysis Services knows the problem, it will drop the aggregation, but it won't be immediately obvious that that aggregation has been dropped. You can tell whether an aggregation is processed by running a DMV query. So this is a DMV query that will look at the aggregations on a particular partition. So it looks at the discover partition stat DMV, and here I'm filtering it so that I only look at a database, a cube, a measure group, and a partition. And then here it will show you not only your partition, but it will also show you all of the aggregations built for that partition, and it will also show you the size, the amount of space taken up by that aggregation. Now here I can see that my partitions are processed because I've got a non-zero value. If you have aggregations on a partition that are not processed, aggregation size here will show 0. And if you've done a process update, if an aggregation has been dropped, it's not processed, it can't be used to improve query performance. It needs to be processed again. So what can you do? Well, what you have to do is always, as the last thing you do in your processing, do a process default. I think this is the easiest thing to do. So whatever you do in integration services or whatever you do when you're processing your cube, always as the last thing you do a process default on your cube. What this will do is it will only rebuild anything that's in an unprocessed state. So in this case, it will rebuild any aggregations that have been unprocessed as a result of the process update, and it will bring your cube up to a fully processed state. If your cube is already fully processed, the process default will finish almost immediately, but I don't think there's any reason for anything to be unprocessed in a production cube. So it's a good practice, I think, to do a process default on your entire cube. It's the very last thing you do in your automated processing. Now, the last thing to talk about for MDX calculations, non-empty behavior. So non-empty behavior is a property of an MDX calculated member. And I would say that it's probably the least well understood property of a calculation in analysis services. If we go back to Visual Studio and, for example, we create a calculation, and let's do it in form view. Let's create a new calculation called calculated member, and let's just say it's going to be sales amount times 2. We have this property here, non-empty behavior, which we can set to be a measure. We can set it in various different ways, but you can set it here to be just a measure. Now, what this property does is that it says if the real measure that I've selected for my non-empty behavior property is null, then the calculated measure that we're creating will be null too. And this is a performance optimization property. Doesn't do anything apart from, or shouldn't do anything apart from optimize performance. Because if you've got a complex calculation in your MDX, then if Analysis Services knows this calculation will return null when another real measure returns null, when it's filtering out empty values for a big pivot table, whether it's doing a large number of calculations, it doesn't need to do the calculation because if it knows in advance that the calculation will return null. So this was a really important performance optimization in Analysis Services 2000 and 2005. But in Analysis Services 2008, it was mostly rendered redundant because the Analysis Services dev team did a lot of hard work to try and make the formula engine understand exactly when non-empty behavior could be set and understand that automatically. So now if you're working with Analysis Services 2008 or later, it is very, very unlikely that setting non-empty behavior is going to give you any performance benefit because the formula engine will probably be guessing or making the same assumption for you automatically. However, the big problem with non-empty behavior is that quite often people don't even understand what it does and they set it incorrectly. And if you set it incorrectly, then you can get, at best, just nothing happening, but at worst you can get incorrect query results. So let me show you an example. So what I've got here is an MDX calculator, a couple of MDX calculations and a query. And what this does is I say, well, let's just look at the now function, return a string, and then use that to generate in another calculated member here the name of a measure, internet sales amount. Now here I've got the non-empty behavior property commented out, and my query returns 1,887 rows. This is the correct result for this query. It's a bit of an obscure query, but I've written it to illustrate the point. If, however, we clear the cache and we run this query with non-empty behavior set, and I've set it incorrectly here, when I run the query, you'll see that I'm actually now only getting 65 rows. So I've set the non-empty behavior property incorrectly, and now my query is returning incorrect values. It's actually this non-empty here in my query is filtering out rows which aren't actually empty. It's hiding values that I should be seeing. Why is this incorrect? Well, I'm saying that my calculation here will always be null when reseller sales amount is null. But in actual fact, what I'm returning back here is the value of internet sales amount. And internet sales amount is not null when reseller sales amount is null. Now, here I've given the wrong hint to Analysis Services. It's doing a non-empty filter on rows, and it says, well, I don't need to do the calculation because I know that when reseller sales amount is null, I can just do the non-empty filter. I know that the calculation will be null. It filters out the rows where reseller sales amount is null, and therefore we lose the values for internet sales amount that we should be seeing. So in general, with non-empty behavior, just don't set it. Unless you really, really, really know what you're doing and you can prove that it gives you the correct results in all cases, and you can prove that it gives you improved query performance, you should not be messing around with it. Yes, it's an important performance optimization on 2005, but on 2008 and greater, I think I can remember one example in the last 5 or 6 years where it did genuinely make sense to set it. And the good rule that you should always set is that if you can rewrite your calculation to check for null values, setting the non-empty behavior property is going to be effectively the same as using this kind of construction in MDX to say, well, if my real measure is empty, return null, otherwise do the calculation. If you can rewrite your calculation to do that, then you probably should, and again, it's not worth setting the non-empty behavior property. That takes me up to my hour. I've got some more things to say in my slides, but that was only in case I didn't have enough stuff to fill up my time. I'm finished. Thank you for listening. But if you do have any questions, I am happy to take questions now.
Okay, excellent. Thanks, Chris. We do have a few questions. Maybe we just read through them now, if that's okay.
Sure.
Okay. So the first one is, how would you handle requests for abbreviations which turn measures to be a little bit more imprecise? And then the audience asks that they've often realized that the users put down the well-described measures as work factor initial by acceptance date, and then they would like to have it abbreviated like WF planned.
Showing abbreviations is, I think, a valid request from an end user, because sometimes you have quite long-winded names, and if you're building a report, then yes, having abbreviations for things like measures does make sense. I think the rule you have to apply is, does the request come from the person who's actually using the cube, or does it come from somewhere in the IT department to somebody who's trying to apply a naming convention? I would say the rule you should have to follow is the customer is always right. If the end user wants these abbreviated names, then, well, if the end user understands these abbreviations, that's fine. But you have to make sure that it's not some power user, not some guy who's been kind of seconded onto your project who is making a decision on behalf of everybody else, which is incorrect. It's always a good idea to make sure that it's not just this one guy's particular preference, but make sure it's okay with all of the user community.
Okay, excellent. And then the second question is, how would you handle aggregations that are needed just once in a quarter? It might be important not to delete them.
That's a big problem. If they're only used very occasionally, you just have to make that decision, well, do I need them at all or not? It really depends on how much extra time they're adding onto your processing. If they're only adding a very small amount of extra time onto your processing, then by all means have them. But if they are causing a big problem for processing, then maybe you need to get the end user to accept that that report they're running once a quarter is just going to have to be a little bit slower than it needs to be. I mean, remember, it's not always a zero-sum game. You can build an aggregation that takes only a couple of seconds to process that can take minutes and minutes of the time taken for processing for running your query. So there's always got to be compromises. But I would say that if you have got a report that probably does need an aggregation, well, you probably should think about keeping it inside your cube.
Okay, and then we've got one last question. All right, so the question is, I used less than equal sign in partition. How can I use this in cube slice property? I'm talking about partitions with query-like date dimension.
Okay, so you're talking about the cube slice property on a partition. The cube slice property on a partition does not do the same thing as anything that you can do in the SQL for the source of your query. So I guess what you're doing is something like where date key is less than or equal to, so something like that. Now, what we're doing here in the partition is defining what data is actually being brought back into the partition. This is something you have to do anyway. This is something that you always have to do. You can't get away from doing this. You can't replace this with the cube slice property. However, or the slice property, the slice property does something different. The slice property has two functions. The slice property in a partition gives analysis services a better idea of the data that's in a partition, and this allows analysis services to only scan the partitions that contain the data that it needs for a particular query. So you might have a partition that contains a where clause in SQL that restricts your data in this partition to be just, for example, the year 2001. Now, if you've got multiple partitions, then analysis services, when it processes that partition, will do its best to try and understand what years of data or what data exists for every attribute on every dimension inside that partition. And in a lot of cases, it does quite a good job, but it doesn't do a perfect job. So what the slice property does is that it actually specifically tells analysis services what data is inside the partition. It doesn't filter the data inside the partition, but it's just an extra layer of metadata that tells analysis services, this partition should only contain data for the year 2001. And it can use this metadata when queries are running to make sure it only scans the partitions that contain the data that are needed. The slice property has a second function as well, which means that if you say this partition should only contain data for 2001 and something goes wrong and it contains data for 2002, during processing, if the slice property is set, it will fail if it sees data in the partition that doesn't match the slice. So it's a kind of safety mechanism as well. But in general, you will be having a where clause in the SQL used for your partition, and you will be setting the slice property. The slice property does not replace the where clause. It's an extra thing on top.
Excellent. All right, actually we've got one more question. I think we'll wrap that up. All right, it says, do you need to run a process default after a process increment when adding new cube data?
You're talking about an incremental process on it depends on whether it's an incremental, well, if you're doing a process add on a dimension, then yes, possibly you may need to, because you might need to add new data to existing aggregations. If you're doing an incremental process on a partition, then no, you shouldn't do. But like I said, I think it's good practice to always do a process default as the very last thing you do during your processing. Because if process default is not doing anything, it's going to only take a couple of seconds. But in case you have done something that does require further processing, the process default will do that processing for you. So it's almost, the question should be not whether it's required, but it's like, again, it's a safety mechanism. If something has happened which does need some processing, that process default will do whatever processing is necessary. So I don't think in your case you need to do the process default, but it's a good thing to have there just in case somebody's done something that does require some processing.
Okay, excellent. All right, thank you so much, Chris, for delivering the presentation today. That was really useful. I learned lots of good stuff today. So I hope the audience feels the same as well. And just a reminder, this session is recorded and will be posted on the YouTube channel, which is youtube.com/user/PassBIVC.
Cool. Thank you.
All right, thanks, Chris. Bye.
Bye-bye.